Welcome to Integrated Science Intervention Program for Senior High Schools. The topic for today is mole concept, and the lesson title is Moles in Mass of Atoms. I am Esiama Kufuor, your facilitator. In our previous lesson, we determined how to calculate the number of moles from a given number of particles. You were given assignments. You have 20 seconds to present the second assignment, which is the challenged question. You can start with. Welcome back. Let us see how you solve the question. The question was, calculate the number of molecules contained in 0.8 moles of nitrogen gas, given that the L, that is Avogadro's constant, is equal to 6.02 times 10 raised to the power 23 molecules per mole. Now, using our usual problem-solving strategy, you will see that we were given lowercase n to be 0.8 moles, uppercase L, which is Avogadro's constant, to be 6.02 times 10 raised to the power 23 molecules per mole. And the quantity being sought for is uppercase N. Now, how do we solve this question? By definition, lowercase n is equal to uppercase N divided by what? L. This is the mathematical expression of a mole. But we are looking for uppercase N. So how do we make uppercase N the subject of this formula? You will agree with me that we have to multiply both sides of the equation you see on your screen by the denominator, which is L. And the expression is what you see on your screen. Now you can see that we have uppercase L as a numerator and as a denominator in one arm of the equation. So they can cancel out. And the result will be uppercase N is equal to lowercase n multiplied by L. Let's substitute our values. And if you substitute the values, it will give us uppercase N is equal to 0.8 moles multiplied by 6.02 times 10 raised to the power 23 molecules per mole. You can see from the expression that mole will cancel per mole, and this will give the final answer to be uppercase N is equal to 4.82 times 10 raised to the power 23 molecules. I hope you all got the answer correct. In this lesson, we are going to continue by looking at the relationship that exists between a mole of a substance and its mass. In this lesson, we are learning to explain relative atomic mass of an element. Then we will calculate the number of moles or amount of substance in a given mass. The lesson has been structured into two sections. In section 1, we will be looking at relative atomic mass. In section 2, we will calculate the number of moles in a given mass of a substance. The key words in today's lesson are relative atomic mass, reference scale, and amount of substance. Let us begin with relative atomic mass. How do we determine the mass of an atom? An atom is a very small particle. So there is no instrument that can weigh out directly the mass of an atom. To find the mass of an atom of an element, scientists use carbon-12 as the standard unit or the reference scale. Now, one atom of carbon-12 has 6 protons and 6 neutrons in its nucleus. So, to find the mass number of carbon-12, we will have to add 6 protons to 6 neutrons, and it will give us mass number of 12. Now, dividing the mass number by 12 units gives what we call 1 atomic mass unit, and that is a single unit of carbon-12. And this is what we are going to use to compare with the masses of the various atoms. This is the reference scale for measuring the mass of all other atoms. So, that single unit, which is a unit of carbon-12, is also termed as 1/12 the mass of 1 atom of carbon-12 isotope. How do we find the mass of a single atom of an element? Let's take a single atom of nitrogen. Nitrogen has 6 protons and 6 neutrons in its nucleus. So if you find the mass number by summing the number of protons and the number of neutrons, you will get 14. So the mass number of nitrogen is 14. Now, to find the mass or the relative atomic mass of nitrogen, this can be done by comparing it with 1 atomic mass unit, or 1/12 the mass of 1 isotope of what? Carbon-12. So, if I place a single atom of nitrogen in one arm of a balance, and I place 1 unit of carbon-12 in the other arm, it will tilt towards the nitrogen atom, because nitrogen atom is 14 times as massive as 1 atom of, or should I say, a single unit of carbon-12. So, how can I make the scale on your screen balance? I'll have to add 13 units, atomic mass units of carbon-12 to it, so that an equilibrium can be established, as you can see on your screen. When an equilibrium is established, then we say that we have balanced the 2 arms. Now, the mass of 1 nitrogen atom is 14. That is its atomic mass. But when I compare it with 1 atomic mass unit, if I compare it with 1/12 the mass of 1 atom of carbon-12 isotope, then it is termed as relative atomic mass. So therefore, the mass of nitrogen atom compared to 1 atomic mass unit, or the mass of 1 nitrogen atom compared to 1/12 the mass of 1 atom of carbon-12 isotope, is its relative atomic mass, and this is simply equal to what? 14. Let us see how we define relative atomic mass of an atom of an element. It is defined as the average mass of an atom of that element compared to 1/12 the mass of 1 atom of carbon-12 isotope. Another complex definition, isn't it? Let me break it down into 2 parts. And the two parts have been highlighted on your screen. Now, what it means is that if I take an average mass of an atom of the element, that is, if the element has got isotopes, then it will have different masses. If I average all the masses, the figure that we'll get as the average mass, if I compare it with 1/12 the mass of one atom of carbon-12 isotope, that is what we call the relative atomic mass. Now, relative atomic mass has no unit because the unit of masses will cancel out. But it is numerically equal to the atomic mass. It is usually denoted by uppercase A, lowercase r, and mathematically defined as AR is equal to the average mass of one atom of an element divided by 1/12 the mass of one atom of carbon-12 isotope. So, for example, helium has relative atomic mass of 4. This means that one helium atom is 4 times as massive as 1/12 the mass of one atom of carbon-12 isotope. Similarly, oxygen has relative atomic mass of 16. Oxygen has got number of isotopes. So if I average all the masses of the isotope, then the figure that I'll get is 16 times as massive as 1/12 the mass of one atom of carbon-12 isotope. So that is what we mean by relative atomic mass. Let us now turn our attention to the relationship that exists between the mass of a substance and the number of moles that are contained in it. How do we determine the mass of a given number of moles of a substance? Let us go through this exercise together. If I give you 1 mole of nitrogen atom, how will you determine its mass? You will agree with me that it is determined by multiplying 1 by the relative atomic mass of nitrogen, which is 14. And that will give us 14 grams. Correspondingly, if I give you 2 moles of nitrogen, how will you determine the mass? As usual, this is done by multiplying 2 by the relative atomic mass of nitrogen, which is 14. And that will give us what? 28 grams. Similarly, if I have n moles of a substance, how will I determine its mass? It will be done by multiplying n by the relative atomic mass, and that should give us lowercase m grams. If we extract the latter part of the derivation, we arrive at this expression you see on your screen. That is, lowercase m is equal to lowercase n times AR. Now let me ask, how can we make lowercase n the subject of this formula? As we did previously, it means you will have to divide both sides of the equation by the quantity which is attached to n. That is the quantity which is multiplying n. And in this case, when we do that, we will arrive at the formula lowercase n is equal to lowercase m divided by AR. Now, let us solve a question using this formula. So take your pen and paper and solve this question. Calculate the amount of substance contained in 16 grams of calcium atoms, given that the relative atomic mass of calcium is 40. You have 20 seconds to present your work. You can start work. Welcome back. I hope you were able to get the answer. Let us see how you should have solved the question. As usual, we will have to extract the known quantities and list them. Then you ask yourself, what quantity am I looking for? And that will be our own unknown. So in this question, we are given M to be 16 grams, relative atomic mass of calcium to be 40. And we are looking for amount of substance, N. So we need to state the formula that we are going to use. By definition, N is equal to lowercase m divided by AR. When we substitute the values into the equation, we will get the expression on your screen. Then, when you solve it, you will arrive at N is equal to 0.4 moles. Then, as usual, you have to check whether you have given the correct units to our answer, or you have to check whether you have not omitted the units. Because as I told you earlier on, omission of units attracts a penalty, and wrong unit also attracts a penalty. Note again that in calculation questions, you are expected to show all the relevant stages to score the maximum marks. We don't just mark the answer, but we mark all the relevant stages, and they all attract mass. So take note. All too soon, we have come to the end of our lesson for today. What have you learned today? Today we have learned that the relative atomic mass of an element is the average mass of an atom of that element compared to 1/12 the mass of one atom of carbon-12 isotope. We also learned that the relative atomic mass has no units. Then we also learned that the mole of a given mass of a substance is a ratio of the mass to its relative atomic mass. Let me leave you with these exercises to try your hands on. Question 1. Calculate the number of moles contained in 1.5 grams of aluminium atoms, given that the relative atomic mass of aluminium is 27. Question 2. Calculate the mass of 0.5 moles of magnesium atom, given that the relative atomic mass of magnesium is 24. In our next lesson, we will look at moles in solution. Thank you for having me. Keep on.